Hello and welcome back. We're going to continue on with hybridization, and we're going to be looking at the hybridization of carbon in the following molecule. Remember, the first thing that you should always write out is the electron configuration, followed by the orbital diagram. So for the case of carbon, the electron configuration is helium, 2s2, 2p2. Well, once we do that, we write out the orbital diagram. We see that we have two half-filled orbitals. However, we have to look at our molecule in order to determine how many bonds are we going to need and if we need to excite any electrons to a higher orbital. In this case, we have two single-bonded hydrogens, so those are two sigma bonds, and we have a double-bonded oxygen, so that's a pi bond. Well, in this case, we know we're going to have to promote an electron to the unfilled p orbital, to the empty p orbital, so we can have the following type of orbital diagram. By doing so, we now have four half-filled orbitals, so we can have four areas to potentially make a bond. When we look at the hybridization, you have to look at the molecule because in this case, we know we need an unhybridized p orbital. When I say unhybridized p orbital, that means one of the p orbitals is not going to participate in mixing for hybridization. It's very important that you note that every time you have a double bond or a triple bond, you have to have unhybridized p orbitals. So in this case, for hybridization, we're going to have one s orbital and two p orbitals participate in hybridization. So when we hybridize, we're going to have three hybridized orbitals of equal energy, and they're all going to be sp2 hybridized, because that's one s orbital with two p orbitals hybridizing, where the unhybridized p orbital is going to continue to form the pi bond. Remember, you need an unhybridized p orbital in order to have the overlapping of its orbitals. So the hybridization for carbon in this case would be sp2. Thank you.